Hey everyone, it's Jake Clark, John Schneider, and Eric Faldy today at the Fargo 3D Printing Show. We're going to talk about some common 3D printing issues and the solutions to those. So, what do we got up first there, John?
Clogged extruders.
Ooh, the joy of clogged
I guess I
extruders.
should, I helped make this list at least a little bit. I'm Eric, by the way, if you don't recognize my voice. But we looked mostly at FDM just because that's more what we work with here in the shop, and just I guess more people would be working with that as far as like a desktop solution. So FDM is mostly what we're going to cover.
Yeah. So clogged extruders, I'm sure if you have a 3D printer, it's something that you've had to deal with, whether it doesn't really matter if it's been a commercial grade 3D printer or a desktop grade 3D printer. I can almost guarantee that you've dealt with it. Maybe the amount of times you've had to deal with it differs between a personal desktop 3D printer and a more professional grade 3D printer, but it's something that happens. So I guess one of the root causes for clogged extruders is just dirty filament. There's a few different causes, but dirty filament is probably one of the main ones. This is if you have a physical piece of dirt or dust that is in your filament. Maybe it's just really inexpensive stuff, wasn't made in the greatest place, but it is what it is. Now that's clogged up the little tiny hole in your nozzle, and now you've got a backed up extruder. So that's one cause. Another cause of clogged extruders, and this one is, you won't know it right away, but it comes from the filament swelling up. So if you've ever had to dismantle your extruder and you pull the filament back out of the top and you notice that it's a normal sized filament all the way down until maybe the last quarter to half an inch, and it seems like it's a larger diameter. That happens just because the filament swelled up in the nozzle, or probably even in the thermal barrier tube, and it couldn't move any further.
Just stuck to the sides and just couldn't push.
Yeah, so there's a few different causes of that swelling. I guess one is, so sometimes it'll be moisture content. Just PLA.
Especially with PLA.
Yeah, PLA. Nylon also has this problem because they're hydroscopic.
Hydroscopic or
Hydroscopic.
hydraulic?
Nope, hydroscopic. Because hydroscopic means that it sucks moisture from the air because it has a negative pressure or something. It has a...
We're going to get a verification of this.
Yeah, no,
I'm Googling.
I'm telling you, well, because the opposite of hydroscopic is hydrophobic. Hydrophobic means that it pushes the water away. So hydroscopic means that it absorbs the water. So all right, we got Jake running the Google search here.
Sorry, I'm a little slow.
Oh wait, okay, you typed in hygroscopic.
Oh, sorry.
I don't know. Well, no, wait. Hygroscopic. Let's. Actually, yeah, there you go. I was wrong. It's not hydroscopic. It's hygro with a G. H-Y-G.
Mm-hmm.
Says hygroscopy is the ability of a substance to attract and hold water molecules from the surrounding environment. This is achieved through either absorption or adsorption, with the absorbing or adsorbing substance being physically changed somewhat. So... I mean, there you go. PLA sucks up moisture. Nylon sucks up moisture. Well, and the crazy thing is, so this will actually cause your filament to physically swell, because when it absorbs moisture, that moisture's got to go somewhere. It causes the small PLA particles to become swollen. It causes them to become larger. And when you're trying to push this through an extruder, it's now heated, and so it's already larger than it's supposed to be being pushed through that thermal barrier tube, and now it might start sticking to the inside of that, which causes even more pressure. You also might notice a lot of swelling if you're doing a print where there's a lot of retraction going on. So retraction, if you think about the nozzle on a 3D printer, it's spitting plastic out and then it has to stop to go somewhere else. To make sure that it doesn't ooze molten plastic out of the end of it, it'll suck that plastic back up. So the drive mechanism will pull the filament back out of the nozzle. So it retracts it, and that's what's called retraction. If you're doing a very intricate part where it's extruding a very small amount and then retracting, extruding a small amount, retracting, extruding a small amount, retracting, this motion of going back and forth, it never allows that swollen part of the filament to be pushed out through the nozzle. So it just kind of keeps sitting there being pushed back and forth until it becomes so pressurized that the filament can't go out through the nozzle.
So something like with dual extrusion, like when you're doing structures with a different sort of filament, is that I mean, I think we've had that happen before with when we're dual extruding.
Yeah, I mean, it's not dual extrusion in and of itself that causes that.
It's retracting so often.
Well, so when it's doing dual extrusion, if you think about dual extrusion, it's not doing one color then another color.
In the MakerBot 2X, it actually pulls the filament back up.
Well, yeah. So, but I mean, most printers will do that. It'll extrude, and then it'll retract the filament that far inside. But then before it starts extruding again, it will
purge.
It'll purge. So it'll push a lot of filament out. So that way, it gets any of that molten part that's just been sitting there. It gets it out of the nozzle. So it's just only pushing out fresh, cooler filament when it's printing. So
Todd is now.
Don't cough on everything. Don't touch everything. Ah. So yeah, Todd. We actually got back in 10 o'clock last night, and Todd had to be at work.
My other job at 7 o'clock this morning.
You do sound sick.
I was up at 5:30.
Oh, man.
He's got that voice for radio.
Today, ladies and gentlemen.
So what we're talking about, Todd, to give you a recap, we're talking about common 3D printing issues and solutions. So right now we're talking about clogged extruders.
What did you leave off of though? I don't know how we got from.
Oh, swelling.
I don't know how we got. Oh, we're still on. Are we still on swelling?
Well, I think we kind of hygroscopic. So
hygroscopic.
You're talking about retraction.
no, don't look up hydrolysis. Look up.
I know, but I wanted to make sure that I was right.
Look up hydroscopic.
I know, I already did.
No, you looked up hygroscopic.
No, it's hygro. It's not hydro.
Well, all right. Okay. Well, now we know.
It's hygro.
Okay.
Like High Groot, except there's no oot at the end.
I am Groot.
Which is a very good movie, by the way. Watch that on the plane.
I've seen it the fifth time the other week.
Oh wow!
I'm surprised Groot was the only one that died, though. To be honest.
Jake, spoiler alert! All right,
I don't even know this is going to be part of the podcast, so.
Well, why not?
I don't know.
We said we're moving to the new format.
I know, but well.
Anyway, okay, so
so
clogged extruders. So we talked about just dirt particles and moisture. So okay, I guess we should probably talk about the solutions to some of these.
Well, I mean, if you're on your Rep 2, I mean that the one thing that can help with the Rep 2 is, if you push your filament, if you heat up your extruder to the max you should ever heat it up to is about 260. If you heat it up to 260 and put in the preheat, push it through. There should be a little bit of filament that squeezes out. If you pull out really quickly, that should remove the clog. And then you clip it, push it back through. More filament should be coming through now. Repeat the process probably 5 to 6 times. I think we have a video on that. We'll throw a link up on that.
So I actually remembered how to do it because I was like, something got clogged. And I was like, why can I remember you have to pull it in, out. Do that like a bunch of times. Like, I need to turn the preheat up.
Well, and the thing is you could probably go to a higher temperature on the Rep 2, but
you don't want to damage your.
Well, you don't want to damage the plastic parts.
Yeah, because
the main part.
If you go up over 260, you run the risk of melting any ABS parts
in
or
Fahrenheit. That's really hot.
260. Jake, do the thing. So the other thing is, so some of the, and I don't know if MakerBot does this, but I know a lot of 3D printers. They'll have a, what is it? It's PEEK, PEEK. Polyethyl, I don't know, whatever it's a long word, but it's what they use. It's what they use for heat insulation. It's not a good conductor of heat.
500 degrees Fahrenheit is 260. Okay. Sorry.
Yeah, so you run the risk of melting that part on your printer. So that's why if you want to print with a high temp material like nylon, or there's some other, like polycarbonate is another really high temp material. They recommend that you should use an all metal extruder, so that way the metal won't melt when you're printing at those high temperatures. Because 500
500 degrees Fahrenheit.
Yeah, 500 degrees Fahrenheit. Yeah, not something you really want to mess around with.
No.
Yeah.
But I mean, so that's one way to fix your extruder. The other way is to replace the nozzle or replace the thermal barrier tube, or one of the recent ones is to actually use a drill bit that is the same size as the inner diameter of your thermal barrier tube and actually drill it out.
Yeah.
If you know what the inside diameter is, because the second you do that and you catch part of the wall, you screw it up, and then the tolerances are out of spec.
Yeah, because you start getting grooves on the inside of the thermal barrier tube. That will
make it a bigger mess.
Yeah, I mean, when you're looking at the cost of a thermal barrier tube, well, at least the stuff for the replicator tube, it's what, like $9? I think it's $9.
I don't know.
I mean,
something in that range.
For something like that, just replace the part. Because otherwise, if you try and drill it out, one, you're going to need to have the right size drill bit. Odds are good you're going to need to go to McMaster-Carr, order a specialized drill bit, wait for it to show up, and then drill it out. Hope that you don't hit the side walls.
Drill it straight.
Yeah, drill it straight. So you have to have a drill press.
$9.
So I mean, If you can do it, yeah, do it. I mean, go for it. But the odds of being able to do it successfully.
There's also an issue of damaging the threads as you clamp it and things like that.
Right.
So
Yeah.
Just buy a new one. It's cheaper, less headache. It'll get to you in no time at all.
Yeah. So that's kind of how you fix it after it's happened. But some preventative maintenance or preventative things to do to avoid getting a clogged extruder. So to try and keep dirt out, if the dirt is actually part of the filament, if it's inside because it's really cheap, crappy filament, there's nothing you can do aside from switching to new filament, and that's what we'd recommend. Go with a higher quality filament. But if it's dust that maybe they're static and it's sticking to the outside of the filament, I know if you go on Thingiverse, there are a couple different things that you can download, and you basically put a sponge on the inside. And I mean, we're not talking about getting every single particle of dust off, but I'd say it gets 90 to 95% of it off. So that's going to at least extend
So that'd
the
be
life.
like an attachment of some sort?
Right. Yes,
Okay.
that would be basically your filament goes through that before it goes through the extruder. So it's not terribly high friction or anything, because you don't want to make the extruder work too hard to pull the filament through, but it will help to get some of the dust off. And then on the moisture side of things, for PLA, I mean, really this goes for any filament, especially if you live in a humid climate. Keep it in a sealed bag or in like a Rubbermaid container or Tupperware with some sort of desiccant in it. So whether it's those little desiccant packets, I'm sure you can go to Uline and get a whole big bag of those. Or I know some people will use rice, similar to, if you think of it like the cell phone trick, where if you get water on your cell phone, put it in a container of rice, it'll help absorb the moisture from it. And another one I've heard of is using kitty litter.
Oh.
Meow.
Yeah, so I mean that's
cheaper than rice, I think.
well I don't know if it's I suppose for the volume it might be
Yeah.
cheaper.
Let's
I'm
just
not
hope
sure.
you don't use used kitty.
probably a little more dusty.
Yeah.
Right. Yeah.
You're talking about dirt in the filament. I was like, is there dirt filament that I
Well,
don't know about?
no, and part of that is the recipe actually behind it. Is the recipe of some filaments aren't great. I mean, they could have just taken any old ABS that's, maybe regrind, maybe it's virgin material, maybe it's recycled. You don't know what that is.
Right.
So really, the part of that clogging could be the material is just made from bad ingredients.
Or the wrong glass temperature, so it turns into liquid plastic too soon, or at too low of a temperature, or it doesn't turn into, or maybe it might have too high of a liquefying temperature. So yeah, it starts getting soft and rubbery at the same point, but it doesn't turn into a liquid until it's a much too high temperature for your printer to handle.
Well, yeah, think about mixing two different ABSs with two different TGs. That's the what we're talking about, that number. If you have something that goes at 100 TG versus mixing it with something that goes at a 260 TG, all of a sudden you got two completely different materials mixed together with two different properties that react differently.
One's going liquid and one's just going rubbery.
Yeah. So I mean, it just causes a mess. But I mean, that's how you with the clog extruders. That's the issues with it in FDM and kind of how to solve that. So support structures, gentlemen.
Well, support structures are kind of, I mean, this is a
That's kind of more of a solution, but
right. Well, I mean, I don't even really want to call.
I just don't. I don't like.
Well,
putting
it's
them up.
you
It's
could
the problem.
you could say it's an issue if you don't know what needs supports and not. So if you're printing something with some really drastic angles and you're like, oh, this will be fine to print. No, it has an overhang. Or for instance, if you're printing a G.I. Joe figurine with his arms outstretched and you think that's going to print beautifully with no supports, I'm sorry, but you're going to need supports with that because it's going to air print and it's going to turn out like crap.
You might not even get anything that looks like an arm.
No, I mean, you might get an amputee there.
And it some of it will come down to the materials that you're using too. Something, for example, so PLA holds up much better to extreme angles than ABS does. So if you're trying to print something with an extreme angle, it might print just fine in PLA, but if you try and print that same model in ABS,
Good luck.
yeah, it's going to end up droopy, and it's not going to end up very well. So the other thing is support structures. They vary widely from software to software and from printer to printer. So if you look at different slicing software, you have Slicer, Cura, Simplify 3D. I think there's another one out called Matter Control, and I'm sure there are some of the more proprietary ones. So I know 3D Systems, they have their own slicer for Cube and Cube Pro, and they all generate supports differently. And some of the softwares like Simplify 3D and Mesh Mixer, you can specify where you want the supports to be. So if you think okay, you don't want it to automatically generate supports. You only want it to have supports in very particular spots. You have the ability to do that. So, I mean, supports can be a pain to clean off too. So if you have some sort of dissolvable support, that usually works better. But keep in mind, if you're working with a printer like the Cube Pro is a good example of this. If you're trying to print your model in ABS and have your supports in PLA, now it's not going to heat the chamber up all the way. So while it's going to print the support structures just fine in PLA, your model in ABS is not going to be as good because now the temperature is not as hot as it needs to be. So now you start running into warping and cracking. So the MakerBot Replicator 2 handles 2X handles dissolvable supports really well.
Well, and it uses a different material.
Well, right, yeah. So that uses, instead of
High
PLA,
impact.
so high impact polystyrene, or HIPS for short. And the printing temperatures for HIPS and ABS are nearly identical. So
Very comparable material to ABS. I mean, 250C versus 230C. So 250 for HIPS, 230 for ABS. Bed at 110 is what we've been using, and I mean, we get great adhesion. Spray a little alcohol on the platform, and I mean that stuff dissolves away in delaminating beautifully.
yeah. So I mean, when you're using dissolvable supports, you can't really reuse the material that you've dissolved, but you're able to dissolve supports. It allows you to print more intricate stuff. So I mean, that kind of crosses over into cleanup. Cleanup on a 3D printed part. Support, if you use a support structure, that's going to be your biggest thing, is taking the supports off, especially if the supports don't come off easily. You have to take an X-Acto or a Dremel to it. If you have a really delicate print, it starts to get a bit messy.
And
It's
I mean,
melty, some of the, as you go in there with the Dremel, no
Oh, yeah,
matter
the
what
friction.
type of tip, the friction heats the plastic up and you end up with, kind of a gooey, sticky film that kind of develops there, and you never do get it quite cleaned down nice and
I was cleaning up that Fox
Finished.
bottle that I made. I believe it's
what did it say? What did it say, Eric? Did it say
It
anything?
didn't say anything. But I was cleaning it up. Like it is. Voronoi is like it's pretty much like I'm trying to think of what it is. Like kind of like the paper. What is it? It's like a Photoshop filter. The one that it's like this elephant that you can't see because it's audio only. But it looks like I think it's the stained glass Photoshop filter. Is like uses the same kind of geometric stuff. It just like approximates distances and stuff. So it looks like a kind of exoskeleton or like a
Swiss
like
cheese.
a weird mesh.
Like a Swiss cheese
yeah.
skin.
Yeah, it's mostly holes.
Yeah.
But I was cleaning it out with a lighter because it takes care of the little wispy parts really well. Like just the spider webbing that you get, the drool from when it's moving around.
Is that how it has a hole in the back of its head?
I melt it. A little drop of it landed right here on my finger, and it just
polymer burn.
Yeah, it was super hot.
So is that how it got a hole in the back of its head there, or is that
No,
just how?
that was because I printed this elephant was printed in the flexible material,
For
and I don't think
MakerBot?
I was doing the temperature right. I tried a bunch of different ones.
Yeah, you have to do it like at a lower
It
temperature.
said it was at 120, but it didn't print very well at 120
and the feet are black because
because I switched from black filament.
Oh, okay.
No, that wasn't. No,
I thought you were starting it on fire down there.
no, I thought I cleaned. I thought, yeah, no, it was.
We're into elephant cooking now.
This one would have melted really badly.
He's been walking away.
No,
But-
we did a dumb. I guess it was my idea. One of my friends, I was like, I want to print something for a white elephant gift, but I made this fox. He's like, why don't you print a white elephant? So I was doing that last week.
Oh, wow.
We made a post out of it, so I mean, it wasn't a waste of time or material, I guess.
No, the flexible stuff is interesting.
It's weird. I haven't
Try it on the
figured out.
2X. See if the
Okay.
heated bed does anything. I don't know if it does or not.
It might.
Did you have any problems with it sticking?
Yeah, look at the bottom. You can see how bad it was sticking on the
Oh, was it sticking really well or not enough?
too well. Like I
Oh.
think this
Well,
was
that's fine
actually
then.
it was actually stuck into the fuzzy part of the gaffer tape that we put on the bed.
Well, we need to replace ours.
Yeah, I ruined the gaffer tape
We'll
while
need
you
more,
guys
by
were
the way.
gone. It got eaten up.
I'll make more.
Sweet.
But yeah, this one was printed at 230. So this one turned
Oh.
out better than any of the other ones I did.
Well, yeah, because I think I tried it at 120 a while back, and it just didn't turn
It just
out very
doesn't
well.
feed fast. I think you'd have to change the feed speed. Or
The extruding wall.
Yeah, I tried.
rate
I
wall
tried a
extruding.
couple things. Like I tried like 120. I tried 230. 230 I did by accident because I couldn't figure out how to make it print at 230 or at 120. But
Yeah, I think I tried at 110 and it didn't work
I
very well.
tried
one
somewhere
day.
in between, and it was better. Like the hotter than 120 was better.
We got some polypropylene in, which we will try at some
We
point.
think it's polypropylene.
We think it is.
I'm pretty sure it's polypropylene.
It's
It's either polypropylene or polyethylene.
Did you
I think
find
it's-
this somewhere? Or like, how do you not know
top
what it
secret.
is?
Top secret, Eric.
yeah, okay.
Can't say.
I won't
I could
ask any
tell you,
questions.
but then I'd have to kill you.
Okay.
And I really don't have a time for a funeral next
I
week.
like living. So.
Well, that's good.
We're big fans of it too.
I mean, but so I mean, cleanup on PLA. I mean, that's what you can use as, you know, the X-Acto knife, the Dremel tool. If you're using a Dremel tool, like Todd said, be careful what tool you actually use in the Dremel, as it can become mushy. ABS, there's a couple different things that you can do. You can, to make it shiny, and when I say shiny, I'm doing air quotes.
No, you're not.
Well, shh, they don't know that, John. They don't know that. Thank you, Todd.
I made them for
Thanks. So anyway, with that, you can actually do an ABS or an acetone vapor bath. Thank you, acetone vapor bath. Which can actually, what that does is it physically melts the different layers together.
Chemically melt,
Chemically. Sorry, not physically.
not with heat.
So it melts the different layers together, and you get kind of a smooth finish. Now there is some air bubbles that show up, some little dimples in the finished product, and I think we'll try and put a picture up there, Eric.
It's not necessarily watertight then.
It's more watertight than just regular FDM because the layers are melted together like that. But what happens is it depends on the vapor. So, for instance, if you have I'm going to be drastic here, 5-gallon pail of acetone, which is a lot, by the way.
That's a lot of acetone.
But really what you need is about, maybe in that 5-gallon bucket, maybe a quarter of an inch worth of actual acetone that you're heating. Now, what happens is when you're heating that and you cap that, what you have is towards the bottom, you have a higher concentration of that vapor, where at the top you don't. So if you have a tall product such as a flower vase, for instance, what's going to happen is the bottom of the vase is actually going to melt more than the top.
Okay.
So you're going to have, towards the top of your vase, you're going to have something that you can see the layers, where at the bottom it's going to be a lot more droopy, a lot more melted, because it is chemically, like John said, melting it. And then make sure you put that on something like an aluminum plate, because if you just put it in acetone, it'll just melt. So,
Sure.
And whatever you place it on, it's going to melt onto that. So, I mean, we'll put some pictures up, Eric, of the product that
I know, I've
we
seen
did
the
acetone.
the only one thing that I've seen.
Yeah, and we can't really say what the product is,
Yeah.
but we can put
know
some
what you're
pictures
talking
up and show you. Now, this product that we had had a cup insert into it. So what was happening is the acetone vapor was coming around the outside of it, and it wasn't actually going inside of the cup. So the inside is actually not melted, or it's not finished per se. So you can still see the layers on the inside, but the outside has this shiny, almost looks like a glossy spray paint. And yeah, it could have its place. Black probably isn't the best one to do. If you had like a red or an orange or something of that nature, it might have turned out better. I know there's a couple of YouTube videos of some people doing that where it actually turned out pretty decent. But I kind of did a home brew way of doing it, so it probably wasn't the best. But that's one thing with ABS you can clean up.
Well, and so the other thing with those acetone baths, there are people out there that have a way to circulate the acetone more, where it'll help to more evenly disperse the acetone. So if you go back to your flower vase example, instead of having all that acetone that ends up sinking to the bottom, it'll basically have a way to take the stuff that's closer to the bottom, take it up to the top, and that way it'll keep the acetone more evenly distributed. I haven't used any of those, but I know that there were some Kickstarter projects out there for people that had something like this that they were trying to build, and I mean, the big thing when you're dealing with acetone is a fire. Trying to avoid that fire hazard, because I think it has a pretty low flash point.
Acetone mist.
Yeah.
I'll look here.
So is this like a little chamber that you put it in, or how does it work exactly?
So mine,
Maybe you
I
said
do
it,
not
didn't
I do
catch it.
not recommend this at all. I used a paint can
Okay.
and a source of heat. I'm not going to say what kind of source of heat.
But it was a fire.
No, it wasn't actually. It was an oven.
It was an oven.
It was a stovetop, and it was an experiment. So I don't recommend this. Don't try to.
The fire
don't,
department didn't come. That's
no,
a good experiment.
I had a fire extinguisher somewhere in the room. It was, I don't know where exactly.
Somewhere in a room behind the blocked fire
Hopefully
escape.
we find it pretty
It was
quick.
in a break room. So
Yeah.
I was figuring this was at a house.
no, it was
Oh,
actually at
Lord.
a place. We're not going to talk about
Okay.
the place, but it's in a break room
Fair
at a place, and on a stove with a paint can, and it worked. Actually, it worked pretty well for my first try.
For
Yeah.
on a stove in a paint can.
Like I
it
said,
looks pretty
I
good.
don't recommend it. I think that's you, John. Yep. I wouldn't recommend it. I don't recommend it. If you're gonna do it differently, or don't do it at all.
What do most people do with that? Is there like a little enclosure that they buy, or like a fish tank or something? I mean,
Yeah, I
see
mean,
what
some.
you wanna
I
put in
think
it. Not a fish
is
tank,
it
but something similar.
Is it a Bunsen burner? Is that what I'm thinking about?
that's what chemists use.
Is that what it is? A Bunsen.
At least for the heat source.
Like an alcohol burner. Or...
I mean, is this a closed off thing, or is it just?
Yeah,
open
it
on
actually
top,
has
or-
to be
Airtight or
enclosed. Yeah,
something?
people use a Bunsen burner,
Okay.
and then they make a stand, and they put their container on top.
Whatever it may be.
Yeah, so like in my case, it was a paint can. Put it on top, and then they'll heat that, and then you have to have it enclosed because that vapor. To tell when you're really getting good vapor from acetone is if you have, for my case, paint can. I had a glass top to it. When I started seeing droplets accumulate on the top
Okay.
of the glass and actually start running down the sides, I knew that there was enough acetone vapor inside that was actually affecting the part. And once I got to that stage, my ABS part almost instantly turned into the glossy
So it's
finish.
something you have to catch really quick, or else you mess.
You
up.
gotta you shouldn't leave it.
Yeah.
You shouldn't
Yeah.
walk away from this. Because yeah. And sorry, I'm getting distracted here with my internet searching.
Science.
Science. But yeah, you should be watching your product and pull it out every now and then and see how it's doing. I mean, because sometimes 5 minutes might be perfect, might be 20. If you leave it in there for an hour and all of a sudden you come back and you're just left with a molten pool of goo that you're like, well, that was fun. I wasted a lot of time.
Yeah.
But so
This may be where we want to put the disclaimer in about not breathing the acetone.
I was gonna say, like, it's not like
If it can melt
like a
plastic, I don't want to know what it'll do to your lungs.
smell test of some sort.
well, for you it might help.
It might actually kill whatever's alive down there.
And anything between. Boiling point of acetone is 132.8 Fahrenheit, 56 degrees C.
It's really not that hot.
No, it's not. I mean, I was on medium heat. I think mine was about 110 Fahrenheit is what I was doing. 100. I don't remember. It's almost a year ago that I did that. Back in the day.
Sounds like a very good way to burn down a house.
Well, I was in a concrete building, so
Well, you could burn concrete.
Burn the things in the building.
yeah, you could burn the things in the building and the paint on the building, but that's about it. Can you give me a glass of water, please?
No.
Please, I said please.
Hot water.
Oh, you. John's getting me hot water. No, ask for water. You can give me hot.
This glass is dirty.
Well, is it? You're hesitating more than once.
No, it is dirty. I was just hesitating whether I should give it to you instead.
Oh, it's chocolate milk. That's my glass.
It's not a shriveled up spider or anything in there, is it?
Give me a
So
minute, I'll go find one.
sure there's some somewhere.
I'll print one.
There's one in the bathroom last
Wait,
week,
laser
and I
gun.
didn't. I just left it.
Thanks.
Someone can find that later. Hey,
Thanks.
He's keeping us safe.
Well, I left a dead moth on your table at one
did,
point.
yeah.
I did.
What are you, a cat?
Well, no, this
Leaving
thing.
dead moths around?
Okay, I'm here at the shop. We're gonna tangent here for a second.
Okay.
We're here
for
at the
a
shop.
second.
We're here.
Second's done.
As in you.
God, yes, we as in me and the computer, as we are working on work, are here late at night, and all of a sudden, I see something just fly around in the office. I'm like, okay, it's 1:30 in the morning or 2 in the morning. I'm either A, seeing something, or B, there's something in here. So I sit there, and I'm waiting for this thing, and all of a sudden, it flutters by the light, and I'm like, oh, that's a giant moth. About the size of my thumb. About the size of maybe $50.
Was it a moth or was it a bat?
Mothra sized or
Well, I was gonna go get Godzilla to kill it, but I figured that'd take too long. So anyway, I just threw something at the ceiling at it, and it killed it. I stunned it, fell on Eric's desk, and there it laid till the
Yeah, I
morning.
asked, like, did someone leave this here? No one said anything. And later, like,
Well,
oh,
I
yeah,
didn't want to leave it on Katie's desk because I didn't want her to scream. I
She
mean,
really, I didn't like it very much. Like, I didn't like picking it up.
Jake.
oh well.
I used to live in an old house with a lot of moths, and like the dogs would get to them, and they're just gross and
Wait till the
dusty
box
and-
elder bugs. That's what was bad at
Box
my
elders
house.
are bad. Where are we at? Are we at?
So
are
we're
we
done
done.
with-
Are we
talking
done
about
cleaning
bugs.
up?
We talked about cleanup. I think we covered.
That's
a lot
not
of
on
it.
the list.
Cleanup/bugs. See, I put it on there. So knowing how to model. Let's talk about that. That is probably one of the biggest issues, and it's kind of one of the easier ones to solve per se.
I don't know.
Depends on-
I've never been
depends-
able to get the strut or the pout down.
The what?
Knowing how to model. Sorry, wrong type of.
I was like,
wrong
John's
modeling.
looking it on
Yeah.
on the catwalk.
On the catwalk.
Ooh, I don't know it. Never mind.
Yeah.
Well, you
Just gotta be fierce. Just gotta own it.
Maybe we should just stop while we're ahead on this one.
I don't
Took me
want
a
to.
minute.
I do not want to see you
Okay,
wearing heels.
So the knowing how to model is actually. I mean, we could have a whole episode just talking about knowing how to model.
Give me the brief.
So when a lot of people think about 3D printing, they think, oh, I can just take a picture of something and send it to the 3D printer and it's going to print.
No.
You are wrong, sir.
Let Eric tell you how wrong you are. So I mean,
Rejected.
you can't just take a picture, and even if you have a 3D scanner, you can't just take a 3D scan of something, or at least not an inexpensive 3D scan, and expect it to print well. To 3D print something, you need to know how to create a 3D model, and there are a really wide variety of different ways to 3D model. There's a bunch of free tools out there. There are more advanced industrial grade tools. There are some that are sort of middle of the road, pretty inexpensive, but still very powerful. It's just, I mean, really, I don't want to dive too deep into this because
We could do this for
I mean,
another episode or a...
if you don't know how to model, and even if you know how to create a 3D model in your particular program, you may not know how to create a 3D model that is 3D printable. I run into this all the time with SketchUp. People send me SketchUp files to print, and they will have inverted faces. So basically, think of a polygon flipped inside out. Now, when a 3D printer reads that, it thinks of it as being inside out. That'd be like if someone, it's like, oh, well, just this part of my arm has the skin flipped inside out. It doesn't work.
Yeah, it would print like... It pretty much would print like a balloon in a way, where it just has that one part of the hole.
Yeah. But yeah, so that's the other thing is if you don't have, especially in SketchUp, if you just have a two-dimensional face, but it doesn't have any depth to it, okay, well, it doesn't read it as a three-dimensional object. To the printer, it's just a little 2D thing, so it's not going to print properly at all. Yeah, I mean, it just gets to be a mess.
And even taking files out of professional CAD software, you have to be aware of what your material thicknesses are and things like that, because a sheet metal thickness in a drawing, when you bring that over into a print, isn't going to be enough material to hold any kind of a structure. It's just going to fall apart.
Right.
So you have to beef those up for the print. You can't just take something that you've done in a 3D model and send it to the printer. You have to actually go in and look at those individual parts and say, is this thick enough? Is this going to hold up?
Or if something's going to have
Yeah.
to move, you need to make sure there's a tolerance for that.
Yeah, I mean, I don't know what I was going to say.
I
agreeing.
understand.
I was agreeing because, I mean, and then if you're going to scale it, it's another thing. So, I mean, that's where also the material thickness comes in too, because if you're taking for instance, let's say a 5-gallon pail. In real life, a 5-gallon pail has about, 1/8-inch wall thickness?
Yeah.
It'd be fine to print an 1/8-inch wall thickness, but all of a sudden if you scale that down to the size of a cup, well, now you might be down to a 32nd or a 16th, which is on some FDM printers it can work.
You can do it, but it gets to be really fragile.
Yeah.
All
So
right. I mean, I think that's kind of the knowing how to
how
model.
to solve that, practice and tutorials, education, those are the main things how to solve that. But we can dive deeper in that some other time.
So another one, and this gets to be a sticking point for some people,
Oh.
is adhesion. Adhesion.
Wow, your mother's proud.
Yeah, I know. Man, I'm looking at the audio part, and it's just me talking. So adhesion. This is a big one. Making sure that the print sticks to the print bed, because otherwise, if it doesn't stick, it just starts moving around, sliding around, and you start getting a ball of material.
Glob.
Big glob at the nozzle. So different materials have different
Sticking points.
well, different sticking points, but they have different ideal surface types that they will stick to. So ABS, for example, if you have what is that?
Kapton tape?
No, it's PET tape. I think it's PET.
Kapton PET.
Yeah, they're different, but yeah. So those two types of tape, if they're perfectly clean, so if you take rubbing alcohol, wipe them down before printing, they'll stick pretty well. But as soon as you start having any oil on them at all, or even if you just try and print again, it's not going to stick as well.
Yeah, because ABS has a little bit of oil that it expels when it prints. I mean, not something to be concerned about, but it does. I mean, it's like your finger.
It's a petroleum-based plastic. It's going to happen.
Even with your fingers, there's oil on your hands. So
yeah, there's a lot. Yeah.
I think you need to wash your hands more often, John.
Whatever.
I've seen your phone after you've been talking.
Oh, gross. Yuck.
It's just like it's a picture. It's art.
Oh,
It's
no.
art.
It's art. Face art.
Oil art.
Face art.
I don't think anybody would buy that.
No, I don't
in the
think so.
gallery.
Either. But then again, who would have bought a Picasso?
What's the I'm trying to think the modern art's like. It's like I could make that,
don't know.
but you didn't.
But you did.
I'm gonna throw a bunch of paints on a wall.
So another way that ABS sticks really well is if you have sort of an acetone ABS slurry. So since ABS dissolves in acetone, you basically take a little jar. Make sure that if it's a plastic jar, it's a plastic that acetone won't dissolve. You take some acetone and put some acetone in there. Drop some little pieces of ABS. Let it dissolve. Shake it up. And then you take a paintbrush while the bed is cold and you brush the acetone ABS on there. What this does is when the acetone evaporates, it will leave little ABS particles behind, creating sort of a rough surface on the print bed. So when you print in ABS, now the ABS that you're printing has all those little tiny ABS particles that it can stick to on the print bed, and that's why that ABS acetone slurry works so well.
So is that the scary yellow substance that's in the other room?
Yeah, that green stuff that you spilt
is that
all over.
Is that the normal color, or is that because of
that's
the slurry?
that's because of the ABS.
Okay, that's
Yeah,
right.
because you mix Lulzbot green.
It was the
with
green Lulzbot.
Yeah,
stuff.
and
Yeah,
so
you
what
spilt
happened
that
there?
all
So make
over-
sure
all over the box.
before you shake or stir the container of acetone and ABS that the lid is on tight. That's basically the lid was barely resting on top. I shook it and it went
Just looks
everywhere.
like ectoplasm
I'm never gonna
everywhere.
have you make a martini.
Well, and the thing is, so I had a lot of that get onto my hands, and so the acetone evaporated. Now I had this thin skin of ABS on my hands, and when you peel it off, it's just like it's like if you've ever been really sunburnt, or if you get glue on your hands and you peel the glue off. It's like it's just weird. And actually, it doesn't even peel off that well because the ABS doesn't stick. You have to take. I went down and used Gojo, so it's a type of hand soap that has pumice in it, and you basically had to scrub it. Pumice. Very different. Two very different things.
I can just imagine you dipping
Hummus
your
tasting hummus.
But now, okay,
Just dipping his fingers in
so that's
hummus.
ABS. So that's ABS. Just dipping fingers in hummus, doing some painting on the wall.
It would
just giant jars of hummus. You just hands in, feet in.
Oh man, I'm sure there's some health club that's the thing they do. But okay, so PLA sticks to.
Well, and heated platform for ABS.
Oh yeah, heated platform for ABS. Now PLA sticks to a different type of surface really well than ABS does. For PLA, you need to have a rougher surface. So the ones that we end up using is so you're probably very familiar with blue painter's tape or gaffer's tape being used. So blue painter's tape and gaffer's tape, they have a rough surface on the backside. That allows the PLA, when it's being extruded, to really dig into that rough surface and give it a good hold on the build platform. But you can't just put the tape on there. You also need to spray a thin layer of hairspray on there. I'm not exactly sure what that helps to solve, but I think what it does is
it adds more adhesion. What it does is it just adds a little bit more to grip into, because when that dries on a more of a microscopic level, there's little pores that it can grip into even more. And especially with glass, use hairspray, because you have that glass has such a smooth surface that hairspray just breaks it up.
There's acrylics in most hairsprays, and that's probably what is giving you that adhesion. It's a thin. You're putting down a thin layer of plastic on there. So,
well, there you go.
Yeah. So that's adhesion. Well, and when you start dealing with other materials, so if you look at NinjaFlex, it hardly matters what your print bed is. I mean, we find that the same type of print bed works. The same type of print bed that you use for ABS works great with NinjaFlex.
Heat or no heat?
I'd say no heat. Whenever we print with it, I'll turn the heat bed on, but only to 35 degrees Celsius. Room temp is usually 23, 24 degrees Celsius, so it's not helping that much. It's helping just a very small amount. If you start printing with nylons, different materials, some of the more exotic ones, I haven't had a chance to print with them much, but you have to start using different materials. I've heard of some people, you have to use almost like a thin sheet of plywood for it to stick to, because that way the plastic will dig more in. And some of that has to do with how the plastic warps, or if it's a slipperier plastic.
What did you use with the Fino? Was it was that a gecko board?
Yeah, so I think it's called gecko board. So think of a circuit board, the same type of material that the core of a circuit board is made out of, but now it has a bunch of tiny 16th inch holes drilled in it. And when it lays down a raft, it over extrudes the plastic. So now that extra plastic goes into those holes, and that's how it digs into the build platform. So it sticks very well to the build platform, but it would even cause the build platform to warp because of how well it was sticking to the build platform.
Yeah. Is there any other?
I'm guessing that there were some more. That's just what we thought.
Well,
of quickly.
some of the other ones that I've been seeing is under extrusion. Let's talk a little bit about under extrusion, maybe. So I've been seeing this a lot with the 5th gen MakerBots, the Z18s. We've been seeing that, and some really bad and top surface finishes. So think of printing a cube, and then the top of the cube is really poor. It's got, it's just really thin.
You can see the structure through the skin.
Yeah. So, and that's even with a solid color like red or orange. That's not even with a translucent. So something like that. What's happening there is either your print temperature isn't up, where if your print, so for instance, 215 versus 230. So at 215, we're seeing a lot of this with the 5th gens, where it does that under extrusion. So what's happening inside is the heat is getting concentrated down towards the nozzle, not necessarily in the thermal core where it should be. So what's happening is it's take that back. Let me step back. It's in the thermal core. It's not getting down to the nozzle, and it's not getting up the thermal barrier tube very far. So what's happening is when that material comes down through the thermal barrier tube, it's getting a little preheated. It hits the thermal core. It gets hot. It gets molten. It starts to go through the nozzle, and the nozzle might be, it's, I don't know how much colder, but it's colder than the thermal core. So what's happening is it's cooling down, causing it to not extrude as much material. So that's one thing that's happening. The other is it's not pushing enough plastic. So where the motor isn't pushing enough plastic to keep up with how fast it's actually moving in the XY direction. So it's moving left and right really fast, but the drive gear isn't pushing enough filament out to adequately put enough plastic on the part. So those are the two things with under extrusion, and that same thing is happening with the top layers. Is it's just not extruding enough plastic. And to fix that, bump up the temperature. I don't think you can change the extrusion speed, and I do that with air quotes again, and I actually did that this time.
I saw it.
I believe you.
Todd's blind.
I was deaf.
All four of us are wearing glasses. I don't think we can really call any of the other ones blind. I think we're all in that same situation.
So that's one thing with under extrusion. That's another printing issue, and like I said, to solve that, bump up the drive gear speed or bump up the temperature. It's kind of one or the other. Another thing is keep the drive gear clean. If you don't keep the drive gear clean, what's going to happen is that's going to fill with particles. So think about, for instance, if you're driving down the road and you hit those washboards, if there is no dirt in the washboards, what's happening is they're full. So when there's no dirt in the washboards, you're getting more of that rough bumpiness in the car, where if they're full, you get a smooth ride. Same thing with the filament. If the drive gears are empty, you're getting more rough. It's digging into the PLA filament or the ABS filament.
Where you're going with that?
Don't worry, I had somewhere.
It was good.
Where if the grooves are filled with plastic, what's happening is the filament is gliding over it and not digging in, so you might have no extrusion at all. I could have probably used a better analogy.
But the only
Tire.
so you like the washboard.
You want the car to be you want the car to be bumpy when you're driving
Yeah, okay.
on the washboards.
That leads to good extrusion.
Yes.
Think of a tire and driving on mud. When the tire is clean, you have a lot of traction on the mud, but as the tire fills up with mud chunks, all of a sudden it just spins because it doesn't have anything to grip anymore. So
I'll punt on my analogy. That was really good.
It was a car. You can. It's good.
Yeah, we
same line of thought, just
different ways.
just different way.
That's fine. Yeah. So I mean, that's
Still talking about roads.
yes. We're still in the same department of roads.
We're going down the same road, you might say.
It
The other
depends.
department.
Okay,
Hopefully,
stop now.
hopefully not a Europe road because those are small and dangerous.
You don't have too
and
many
scary.
options there.
That's like a
No.
1.5 cars wide.
Yeah.
People are trying to park.
Think about like 2 go-karts wide and you're driving a Toyota Corolla, which is a little bit bigger than a go-kart. Pretty much your left tire is hitting the white stripe, your right tire is hitting the center stripe, and that's what you're...
Someone else comes, you have to duck out for a second.
Sometimes. There was one bridge where we had to do that, where it was like, I don't know how there's 2 cars that could fit across this bridge.
Or when a bus that's a lane
wasn't.
in the wide half comes through.
Around the corner.
Yeah.
Its ass end sticks out.
Uh,
But I mean, those are the common print things that we see. I mean, with FDM, we'll probably get it once we get more into SLA. We'll talk a little bit more about that.
I'm excited. I was reading about the Form Labs stuff earlier today. I think that's
Yeah,
what
that's an interesting one. We saw it in action. It's got some potential.
it looks a little messy. Like I was reading about it, and it just says you need to fill up the resin to the line. If you fill it above that and it spills over during the print, it voids your warranty. It's like, what?
Really?
They need to make this a little easier. Like honestly, like it's a very complicated and interesting thing, but like if you just fill it up a little bit too much, like you voided your warranty. And it's not a cheap printer. I know.
No,
that
it's like $4,000.
3,300.
it's still, but for like the size of the print bed, it's not. It's a pretty big price. But it's
Well,
cool if you're going for small and detailed things.
Well, the Autodesk one's gonna be fun.
That's called the Ember, or is that the program?
No, you're right. It's the Ember. Spark is the platform.
Spark is the platform. Okay.
Yeah.
That's gonna be an
It
interesting.
looks like a blender, but a really fancy, cool blender with a red
Gonna
shield
make
on it.
milkshakes and margaritas. But I mean, that's I don't know. That's what we have for FDM problems and how to solve them.
Yeah, so I guess on behalf of all of us, to wrap this up,
Oh,
and
somebody's tired.
cut the rambling a little bit. So on behalf of Jake, myself, Eric, and Todd, thanks for listening to another episode of the Fargo 3D Printing
I
Show.
think this was 15 if we're still counting.
15, it probably is.
I think it is.
And we
I
need,
made-
we
I
need to
made the
figure out our
thumbnail.
numbering system.
I think we're on 15.
And you actually listened to the whole thing.
Yeah, so we've so now
Or
that,
just the end to hear that last bit.
so now that we've switched to doing audio only podcasts, we're gonna switch. So when we do videos are gonna be more of a deep dive into a particular topic. Podcasts are gonna be more of a bunch of people sitting around a table and talking about 3D printing, just like this was. If you have any feedback on this format, please let us know. Leave us some comments.
If you have any topics you want us to cover, that would probably be good too.
Yeah, so
Yeah.
So again, on behalf of all of us, thanks for listening. If you want to keep up to date with us, like us on Facebook, follow us on Twitter. On YouTube, we are Fargo 3D Printing, so subscribe to us there. We're also Fargo 3D Printing on Pinterest and Instagram. Yeah. So, all right, thanks again.
Goodbye.
Bye.
Good night.
Here's Todd. So Ben, why are you important? Why are you here?
Wow, that was right from the show notes. Why is Ben important?
Why is Ben important? That is exactly what it is. So tell me why you're important, Ben.
Outstanding. So, I